Yes, there is a question. The pressure of a moistured gas at 27 degrees centigrade is 4 atm. Volume of the container is doubled at the same temperature. Then you are asked to calculate the new pressure associated in the container. That should becomes equal to some x value into 10 power minus 1, which is x. Then you are asked to calculate x is how much. Then x is how much. To understand this one graphically, as being it is a part of physical chemistry, let us go for this one. There is a container, sealed container, there is some liquid in it. There is some liquid in it. That is water. This water is offering some water vapor, and along with this, some gas is present. Altogether, this offers a total pressure of 4 atm. How much pressure it is offering? 4 atm. Out of this 4 atm, some amount is coming from the water vapor. That amount is 0.4. Whereas remaining, the dry gas related pressure will becomes equal to how much? 3.6 atmospheres. Now, all of suddenly what we did is, at the same temperature condition, whatever volume we are filling it as some V liters, now we made it as what? 2V liters. Total volume will becomes equal to how many liters? 2V liters. Then if it is made to 2V liters, then what is the total pressure present inside the cylinder? Whereas the temperature conditions from the first condition to the final condition, temperature remains constant, that is found to be 27 degrees in Kelvin. This is found to be equal to how much? 300 kelvins. That is at 300 Kelvin, a gas cylinder consisting some water having some vapor pressure followed by some gas, dry gas. Dry gas as well as water vapor. Total wet gas offers a pressure of 4 atms. Out of this 4, we came to know the water vapors related pressure will becomes equal to 0.4 atmospheres. Whereas the exact dry gas pressure under initial conditions of V liters is 3.6 liters. Now suddenly that volume is made double by maintaining same constant temperature. By providing some energy, the volume is expanded by maintaining the same temperature, that is 27 degrees centigrade. Then what might be the pressure inside the cylinder? And once again they are asking double the same temperature. Then the new pressure, yes, then the new pressure of cylinder will becomes equal to how much? To go to the solution, to get the solution of this particular problem, first of all what we do is we will evaluate the dry gas pressure. This is dry gas pressure, pressure of dry gas, initial pressure of dry gas, pressure initial of dry gas will becomes equal to how much? Dry gas is 3.6 atmospheres, whereas in this case here temperature remains constant, number of moles of dry gas also remains constant. Let us go for PV is equal to nRT, what to do, what not to do. Whereas in this case, whereas this volume is expanded, volume is not constant, but number of moles are constant, temperature remains constant, this is constant, altogether are constant, implies PV multiplication product under all situations remains the same and constant. That is P1 V1 will becomes equal to what? P2 V2. Whereas initial pressure of dry gas is found to be 3.6, we are claiming its volume is what? V1. Whereas final pressure now we have to calculate, that is final pressure is pressure of dry gas, that is V2. V2 will becomes equal to what? 2 times of V1 because volume is doubled. So therefore that particular P2 will becomes equal to 3.6 by 2, that will becomes equal to what? 1.8 atmospheres. Dry gas pressure dropped to half and it's reached to a final value of 1.8. But there is water vapor. Vapor pressure, water vapors related pressure is said to be aqueous tension. That is also known as vapor pressure offered by the moisture, vapor pressure offered by the water. That water's vapor pressure is characteristic property of the water that is only getting infected or affected by temperature. No other factor causes any change. So therefore this particular 0.4 whichever is present in the beginning, that remains same and constant at the ending, because pressure is an intensive property. Pressure does not depends on vapor pressure, especially vapor pressure does not depends on shape, size of the container, surface area, availability, amount of liquid and all other things. So therefore this is characteristic, though that maybe container is of 2 liters, 4 liters, 10 liters, 40 liters, not an issue. the corresponding pressure remains same and constant as 0.4 atms. So therefore final pressure P will becomes equal to P2 plus 0.4, that is becomes equal to 1.8 plus 0.4 is equal to 2.2 atmospheres. 2.2 atmospheres. This value, as per the question is concerned, we have to express this one as sum into 10 power minus 1, that will becomes equal to what? 22 into 10 power minus 1. Hence the value of x as of question is concerned will becomes equal to 22.